Hi everyone, and welcome back to week 3 of Research and Evaluation. Today's lecture is all about operationalization and measurement. So we talked a little bit about operationalization last week as part of the traditional model of science. So in that model, you start with a theory, which are ideas, you turn those ideas into something that can be measured, and then you measure them. So operationalization refers to the process of coming up with measures for your theoretical ideas. And we're going to go through some terms that have to do with this process. I will say at the outset, in general, I don't care that you know these terms so much as that you are familiar with the process itself. Because as you're going to see, they're all almost exactly the same term and not really useful outside of the concepts that they refer to. All right, so a concept is something that you're probably familiar with. Last week we talked about theoretical concepts, and this is really just another way of saying that. So a concept is some word or symbol that represents a mental image or idea. So if you want to talk about crime, that's a concept. It's a word that represents some picture that you have in your head or some idea of what crime is. We can also think about concepts as having multiple dimensions. So when we think about crime, a lot of different things can come to mind. There's violent crime, there's property crime, there's drug crime, there's serious crime, there's less serious crime. There's lots of different ways that you could break down crime into different dimensions that would each refer to some part of this broader concept of crime. So concept, some word or symbol that represents a larger idea or mental image. The mental image itself or idea can be broken down into smaller dimensions that represent part of that broader concept. A conceptual definition, on the other hand, refers to the working definition of a concept. So let's say that we want to study crime. Crime, as we just talked about, is a big, broad idea. So if you wanted to actually figure out how to come up with a measure for crime, you'd have to come up with some sort of working definition for the larger concept of crime. And it could be that in the study, we're interested in any instance of lawbreaking. That would be a working definition. We haven't gotten to the point of measuring it yet, but we've narrowed this larger, fuzzier concept of crime down to a working definition that we can use to then build a measure from. So the concept is the biggest and fuzziest. The conceptual definition takes that bigger and fuzzier concept and puts words to it, puts a definition to it that we can then use to build a measurement strategy with. So our concept might be crime, but our conceptual definition or our working definition for that concept might be any instance of lawbreaking. Next we get to operationalization. And operationalization refers to the process of turning that concept into a measurable variable, generally based on your conceptual definition, and includes the following steps. You have to think about what attributes will be observed. So if we're measuring crime, and we're thinking of crime as any instance of lawbreaking, we have to think about what are the different values that this can take on. Is it going to be you have ever broken the law or not ever broken the law? Would you count the number of instances of lawbreaking that there would be? Would you consider different types of instances of lawbreaking? These are all things that you would need to think about when designing a variable, or in other words, operationalizing a concept. So you have the idea, you have the working definition, but how are you actually going to measure it? And for example, what are the values that your variable might be able to take on? How will you observe them? This is sort of a more practical question. Let's say that we've decided to measure crime. Our working definition is any instance of lawbreaking, and we're going to measure it in the simplest way possible, which is, have you ever broken a law? How are we then going to measure that? Do we ask people? Do we look at records like arrest records? Do we go through some other sort of archival data? Do we ask people around them as well? There are lots of different ways that you could actually get a yes or no answer on, has this person ever broken the law? And at this point, you'd have to think about which of those options you are going to go with. And finally, you need to think about how observations will be interpreted. So let's say we're going to measure this concept in a relatively simple way. We're going to ask people, have you ever broken any laws? Now, let's say somebody gets that question and they say, well, maybe, but I'm not sure if it was really illegal at the time. How does that then get turned into one of your attributes? Yes, this person has broken the law, or no, this person has not broken the law. So these are all really technical questions that you have to ask yourself when you're turning a concept into a variable that can be actually used and measured. And finally, your operational definition is all those things that you thought about in the operationalization process turned into a more succinct sentence. So your operational definition for this crime variable we've come up with could be any instance of lawbreaking as self-reported on a multiple choice survey. So we ask people, have you ever broken the law? Give them a chance to answer yes and a chance to answer no. And then our operational definition for crime would be having answered yes to the question of whether you have ever broken the law on this survey. So it's kind of like a funnel. You're starting from a broad concept and you're narrowing it down and getting more and more specific until you have an actual measurable variable to use. And for the record, the variable I just described would be pretty terrible from a research method standpoint, but I think as an example, it can be useful. So in operationalizing a concept, you're creating a variable. And we talked a little bit last week about variables and how they are groupings of attributes that are related to each other in some way. I'm going to talk about them again now using a slightly different definition that is a little bit more relevant when you're thinking about groups of people or anything else that you could be studying. So here we could define a variable as a characteristic that differs across cases. And a case would be some member of the population or sample or group that you're looking at. So if you were looking at a group of students, for example, a variable might be the height of the student, the number of semesters they've been in school. These are all things that would be different across the different members of that group. With a variable, you could be looking at variables across any group. So if you had a group of ducks, a variable might be something like beak size. If you had a group of police departments, a variable might be something like number of officers employed in each police department. So whatever your group is, a variable is something that varies across members of those groups. A constant, on the other hand, is a characteristic that does not differ across cases, which makes it the opposite of a variable. So if you're thinking about a group of students, a constant would be that all of them are students. Right, so all of them are engaging in some sort of school activity by being students. If you're thinking about a group of ducks, a constant would be that all of them are birds. So a constant is any characteristic that does not differ across members of the group that you're interested in. Also, as a quick recap from last week, we talked about dependent variables and independent variables. Independent and dependent variables refer to cause and effect. So an independent variable is a cause that affects some other variable. A dependent variable is an effect which is affected by the cause. So your independent variable causes your dependent variable. We can also talk about the characteristics of variables. And last week I talked a little bit about variable attributes. Here is that definition again. So attributes are characteristics of people, places, or things, etc. that are logically grouped together. Because if you remember, we defined a variable as a logical grouping of attributes. So if you're thinking about something like height as a variable, the attributes would be the different heights that people could be. So say height in inches, 50 inches, oh, that'd be a really short person, 60 inches, 62 inches. Those would all be different attributes that the variable height could take on. And when you group all those different heights together, you have a variable called height. If you're thinking about something like gender, attributes would be male and female. They're logically grouped together into a variable called gender. Now, it's really important for statistical analysis and for doing research in general that attributes have a couple of qualities. One of these qualities is that attributes of variables have to be exhaustive. In other words, they have to cover every possible characteristic that could be logically grouped together here. Attributes also have to be mutually exclusive, meaning that there can't be any overlap between the attributes. And I'm going to go through these in examples that I think will demonstrate what they mean a little better. So I want you to think about this question. What's your favorite thing in the whole world? And those of you who took stats with me, which I think there might be a couple in this class, you have definitely seen these before. So what's your favorite thing in the whole world? Is it bowling or is it kittens? Think about that real hard. Bowling or kittens? So there's a slight chance that many of you thought of something else that's your favorite thing in the whole world other than bowling or kittens. So if this were a variable, favorite thing in the whole world, and the only attributes that I included were bowling and kittens, we'd have a problem. Because it wouldn't be covering all the different possible attributes that could be attached to this idea of favorite thing in the world. So the problem here is that this variable of favorite thing in the world would not be exhaustive if it only included bowling and kitten as options. A solution to this is always just to add an other category. So now our variable favorite thing in the world includes bowling, kittens, and literally anything else other than bowling and kittens. So as a variable here, we now have an exhaustive set of attributes: bowling, kittens, and anything else. So no matter what your favorite thing in the world is, it would be covered by this variable. So again, it's important that variables have attributes that are exhaustive, and attributes that are exhaustive cover all possible values that a variable could take on. So in addition to having attributes that are exhaustive, it's also important that variables have attributes that are mutually exclusive. And to illustrate this one, I want you to ask yourself the following question. How would you describe yourself academically? Are you a master's student? Are you a Rutgers student? Are you a research and evaluation student? Or are you something else? So what we see here is that we don't have a problem with the categories being exhaustive. We've covered every possible option there is. You're either one of these three things or you're not one of these three things. But we have a different problem. If asked to choose one, you wouldn't be able to, because you guys are all master's students and Rutgers students and research and evaluation students. So a problem here is that the categories are not mutually exclusive. Being a master's student doesn't mean that you're not a Rutgers student. Being a Rutgers student doesn't mean that you're not a research and evaluation student, and so on. So you get a problem where different cases in your sample could have different observations for the same variable. And so in other words, the attributes for this variable are not mutually exclusive because there's overlap between these categories, and one person answering this question could pick any of those top three answers. A solution to this problem then is to break up a variable like that into multiple variables where all your attributes are mutually exclusive. So are you a master's student? Yes or no? If you answer yes to that question, you can't also answer no to that question. So that variable is okay. The categories are mutually exclusive. Are you a Rutgers student? Yes or no? Again, if you answer yes to one of those, you can't answer no to the other one. So those attributes are also mutually exclusive. And finally, are you a research and evaluation student? If you answer yes to that, you can't also answer no to that, which means those attributes are also mutually exclusive. So in thinking about creating variables, you have to always make sure that the attributes that you include in your variable are exhaustive, so they cover all possible values that the variable could take on, and that they're mutually exclusive, meaning that there's no overlap between the different attributes. Variables can also be described in terms of their level of measurement. And a level of measurement describes a variable in terms of several characteristics. Nominal level variables have attributes that can't be put in order. And I have examples for these as well, so I'm going to go through the definitions and then I will break each one down in a little bit more detail in a moment. So nominal level variables have attributes that cannot be put in any kind of order. Ordinal level variables have attributes that can be put in order, but have no set distance between them. Interval level variables have attributes that can be put in order and have the same distance between each attribute, but have no true zero point. And then finally, ratio level variables have all these things. Where attributes can be put in order, there is a distance between them, and there's a true zero point. So that probably sounds like a whole lot of nothing, so I'm going to go through examples of what these actually mean. So beginning with nominal level variables, we define nominal variables as variables where the attributes cannot be put in order. So you would say that a variable is at the nominal level of measurement if you can't put the attributes in order from least to most. So there's no gradient from least to most, you can't rank them. They're just different attributes that a variable can take on. So examples of nominal level variables are something like race. You wouldn't say that being white or black or Asian is having more or less race than any other group. They're just different values that that variable could take on. Same thing with gender. You wouldn't say that male is more gender than female or vice versa. They're just different categories of gender. Profession. You would not say that an astronomer has more profession than an architect, who has more profession than a marine biologist. So these are all just different professions that people can have, and you can't put them in order in a really meaningful way. Type of fruit. Is an apple more fruit than a banana? Is a banana more fruit than a pear? No, they're just different kinds of fruit. So a variable is nominal if the different values that the variable can take on can't be put in any kind of order from least to most. We also have ordinal level variables. Ordinal level variables have attributes that can be put in order, but there is not the same distance between each of the different attributes. And examples of ordinal level variables include something like police department rank. So you would say that you could definitely put in order police department rank from, say, a line officer to an immediate supervisor to a police chief. You'd say there's a gradient there. Some of those are more ranked than others. And you could put them in order from least rank to most. But you would not say that there's the same distance between each of the categories. So in other words, there's probably less distance between a line officer and their immediate supervisor than there is between that immediate supervisor and a police chief, even though we can put them in order. Something like drink size would also be an example of an ordinal level variable. So you could have drinks that are small, medium, and large size, but as you see, sometimes the small and medium are closer in size to each other than, say, the large. So we could say we could put all these in order, but there is no distance between the attributes that we can expect to be the same each time. Likert scale questions are also an example of ordinal level variables, and these pop up a whole lot when you're designing research, especially in some forms of research. And Likert scale questions often ask you how much do you agree or disagree with this statement, and ask you to rank your agreement on a scale from, say, strongly agree to strongly disagree. And these are ordinal because you can definitely put those attributes in order from least agreement to most agreement, but you wouldn't necessarily say that the distance between strongly agree and somewhat agree is the same as the distance between, say, somewhat agree and neither agree nor disagree. Finally, a fun example of a survey question that would definitely be ordinal would be, how happy are you? I'm very happy, I'm somewhat happy, and everything sucks, throw me in a volcano. So here you can definitely rank these attributes in terms of the level of happiness that they're expressing, but there's a pretty clear difference in how close the first two are to each other versus how close the second two are to each other. Another good way to think of it is that ordinal variables have categories that can be put in order, but they're generally not numerical. So next up are interval level variables. Interval level variables have attributes that can be put in order and have a set distance between each of the attributes, but no true 0 point. And what this means is that these are generally numerical variables, but where a score of 0 doesn't mean that there's none of that variable. And examples of interval level variables include something like temperature in degrees. So thinking about the attributes of temperature, those would be things like the number of degrees that it is on a given day. We could definitely put them in order. 50 degrees is colder than 60 degrees, which is colder than 80 degrees. We can also say that there is a set distance between them. In other words, the distance between 50 degrees and 51 degrees is exactly the same as the distance between 51 degrees and 52 degrees. And you can generally know this when something is measured numerically. There's going to be a set distance in between each of the different attributes. temperature has no true 0 point. And a true 0 point is a point where a score of 0 means that there is none of the thing you're measuring. So think about a day where it's 0 degrees out. It doesn't mean that there's no temperature. 0 is just another value out of many that temperature can take on. Another example of an interval level variable would be grades on a test. And for grades, you can definitely put them in order. A score of 90 is a better grade than a score of 70, and so on. And there's a set distance between them. The distance between 80 and 81 on a test is the same as the distance between 82 and 83 on a test, and so on. But again, we have a variable where a score of 0 wouldn't mean that there was none of that thing. So if you get a 0 on a test, it doesn't mean that you don't have a grade, right? You do have a grade. It's just a 0. So 0 is just another value that that variable can take on. And finally, we have one other category of variables here, which are considered ratio level variables. And ratio variables have all these characteristics that we've been talking about. So the attributes can be put in order. There is the same distance between each of the attributes once they're ordered, and there is a true 0 point. This means that ratio level variables are numerical, and a score of 0 means that there is none of that variable. So examples of ratio level variables are generally anything that can be counted. So, number of murders. 5 murders is more than 3 murders, which is more than 1 murder. We can put those attributes in order. There is the same distance between each of the attributes. 1 murder is the same distance from 2 murders as 2 murders is from 3 murders, and so on. There's also a true 0 point. So if I come in and say, we had 0 murders today, you would know for sure that that meant we had no murders. So there is none of the thing that I'm measuring. Weight in pounds would be another example of this. So you can put number of pounds in order. You'd say that there is the same distance between 5 pounds and 6 pounds as there is between 6 pounds and 7 pounds. And we have a true 0 point. If something weighs 0 pounds, it doesn't weigh anything at all. Distance in miles, similar idea, can put these things in order. They're numerical, so there's the same distance between each one once they're in order, and a distance of 0 miles would mean that there is no distance at all. Number of cats owned, same thing. You could go through all those again, put the categories in order, there's the same distance between them, and if you own 0 cats, you own no cats. So I'm just going to put up a table that recaps this quickly. Levels of measurement are generally most important in statistical applications, but they can be useful in knowing which methods are appropriate. And when you're thinking about how to create a variable, you will ultimately have to make a decision about what level that you're measuring it at. So this is just a quick table to recap what I went through before. We have each of our levels of measurement, and then check yes or no whether the attributes can be put in order, whether they're numerical, so in other words, can you do math with them, and does 0 equal nothing? All right, so now you guys know just about everything there is about the different kind of characteristics that variables can have after you have operationalized a concept. Now I'm going to rewind a little bit and think about how you actually operationalize something. So if you're in a position to do research, or if you're consuming someone else's research, you have to think about how the concept of interest is turned into a measure, so operationalization. And here I'm going to go through an example that I want you to think about. Let's say we want to measure support for marijuana legalization. That's our concept. You probably have some idea or picture in your head of what supporting marijuana legalization looks like. But the question is, how do we operationalize this? And if I told you to just go out now and come up with some measurement for this, you'd probably come back to me with different kinds of things. So for example, you could just ask people, do you support legalizing marijuana? Yes or no? That would be one way of operationalizing it. You could look at something like voting history. That would be another way of operationalizing it, at least if you were in a state that had recently voted for marijuana legalization. You could also think about the different dimensions that marijuana legalization has. So are we talking about medical? Are we talking about use? Are we talking about possession? Are we talking about growing? And so on. And so when it comes to operationalizing a concept, there are a ton of different decisions that have to be made. And aside from making sure that your attributes are all hunky-dory in terms of being exhaustive and mutually exclusive, and thinking about the level that you want to measure marijuana legalization at, you actually have to start thinking about the different possible ways that you could do it. And just a quick note on level of measurement. If you're thinking about measuring it as a yes or no question, you would have a nominal level variable. If you ask people how much do you agree or disagree that marijuana should be legalized, you would have an ordinal level variable. If you were to ask a question of on a scale from 0 to 100, how much do you support marijuana legalization? Now you have a numerical level variable that can be treated a lot more like, say, an interval level variable. So in deciding how to operationalize a concept, you're also deciding the level that you're going to measure it at, which is why I go through those on the last couple of slides. So hopefully at this point you've been thinking a little bit about how you might do this if you were actually given the opportunity to support marijuana legalization. For the purposes of the slideshow, I'm going to give you an example of how I might do it if I were to ask people on a survey how much they support marijuana legalization. So this is just going to be one example of many, many different ways that this question could be operationalized. And we're going to use it again down the line later for talking about how to evaluate how good a measure of something is. So I might use some Likert scale questions, and I'm going to ask people to rate their agreement or disagreement with a couple of different aspects or dimensions of marijuana legalization. So how much do you agree or disagree that possession of marijuana for medical use should be legal? Possession for recreational use should be legal. There should be no penalties for possessing marijuana. People should be allowed to grow marijuana legally. And marijuana should be legal for everyone, regardless of age, is what's behind my head there. And so think about these questions. Would this be a good way of operationalizing the concept of support for marijuana legalization? We've certainly covered a number of different dimensions, and what we might do is ask people to agree or disagree with these statements on a scale like this, and then somehow combine the answers to these questions together. And that's something that we'll talk about way down the line in terms of how you actually do that. But for now, we're going to use these 5 questions to operationalize support for marijuana legalization. So in thinking about that measure, we want to think about whether it's a good measure, and to do so, we will consider 3 qualities that a good measure should have. One is precision. A measure that's precise gives you more information than a measure that is imprecise. So for example, asking somebody whether they support marijuana, yes or no, is less precise than questions asking about whether they would support marijuana legalization in different contexts. You're just getting more information when you ask about something in multiple contexts than when you ask about it in fewer contexts. Another example of precision would be asking someone, have you ever been incarcerated versus how long were you incarcerated? In the have you ever question, you're only getting a little bit of information. In how long, you're getting additional information. A good measure should also be reliable. What reliability means is that if you were to use the same measure over and over again, you would get the same results. And with reliability, we're going to talk about some examples of what that looks like and more specific tests for whether or not something is reliable. But before we do that, we're also going to talk about the third quality of a good measure, which we'll also dig into in a little bit, which is validity. And validity means that there is some sort of truth in what you're measuring. The thing that you're setting out to measure is the thing that you're actually measuring. So a quality of a good measure would be that it's precise, so it gives you a lot of information. It's reliable. If you used it over and over again, you'd get the same results. And it's valid, meaning that it's measuring what it's trying to measure. So precision is pretty straightforward. The more information you get, the more precise it is. But with reliability and validity, there are a lot of different ways to think about whether something is reliable or valid. So that's what I'm going to talk about next. Let's say we want to think about that marijuana legalization support measure that I came up with. We want to know that if I were to use that measure over and over again, whether it would give me the same results. Well, how do we do that? One way of assessing reliability is to do the test-retest method. And that would be using the same measure twice on the same group and seeing if you get the same results. And with each of these, I'm going to go through the definition and then I'm going to go through the example with the support legalizing marijuana measure. There's also something called the alternative form method. And here, you would use a slightly different version of your measure and see if you get the same results. So you're seeing whether slight tweaks are going to give you the same results as your original version. The split halves method. If you have a measure that involves multiple questions, like the one we came up with, or a measure that involves multiple components in any way, you can compare responses on one half of the measure to responses on the other half of the measure. And if they're similar, that gives you some sense that there is consistency in what you're doing in order to measure the concept. There's also something called the internal consistency method. And with this one, you're comparing every single item in the measure to every single other item in the measure. And there is a particular version of internal consistency called Cronbach's alpha that you'll probably see if you read research articles for anything. And it's actually a numerical way of calculating how similar all the items in your measure are to all the other items in your measure. And the higher it is, the more consistency you have. And finally, there's inter-rater reliability. And inter-rater reliability tells you whether people score the same measure in the same way. So if you have two different researchers looking at responses to something, are they going to interpret those responses in the same way? So as I just mentioned, I'm now going to go through each of these different ways of assessing reliability with the example that we had before. So as a reminder, here's the example scale. We have 5 items to measure this concept. We're going to ask people how much they agree or disagree with each of them, and then we're going to combine responses to these items into a single measure of support for marijuana legalization. So how reliable is that measure going to be? In order to answer that question, we might consider each of these different methods. So with the test-retest method, we want to know whether the same people would give the same answers on the measure if tested again. So you could ask a bunch of people to answer those questions, then ask them again in a couple days, and compare the answers they gave the first time to the answers they gave the second time. If they're similar, you'd have good test-retest reliability because you'd be getting the same responses to your measure the first time and the second time. There's also the alternative form method. So in order to test the reliability of the measure in this way, you could word the questions a little bit differently and then give the measure to people who have already taken the first version and see how similar the answers are. The split halves method would involve comparing responses to the first half of the questionnaire to responses in the second half of the questionnaire. So you'd have good reliability if people answered the first couple questions similarly to the last couple questions. You'd have bad reliability, on the other hand, if people really seem to support legalization on the first couple questions, but really seem to not support it on the second couple questions. The internal consistency method is similar. So you'd want to look at responses to all 5 of those questions and see if people are answering them similarly. And a pretty common thing if you're making a scale is that you might find that 1 or 2 items just don't seem to be getting the same kind of answers as the other ones do. And if you think about the examples I had before, one of the questions asked people whether they think marijuana should be legal for any age to use. And I would guess that if you were to give this questionnaire to people, that one might stand out. Because a lot of people might be fine with marijuana being legal, but they wouldn't want a 12-year-old smoking it, just like they wouldn't want a 12-year-old smoking cigarettes or drinking alcohol. You might also see that the question about growing it would stand out, since all the other questions ask about use and that one asks about growing. So with internal consistency, in order to really get at the concept, you'd want to see if people are answering all the questions similarly to each other, or if some of the items are getting different answers. And if everything's getting really different answers, then you would have really, really poor internal consistency. Finally, inter-rater reliability looks at whether the measure would be scored similarly by different researchers or different raters who are rating it. So here the question would be, if two researchers were to look at the answers to those questions, would they come to the same conclusions about how much the person they're looking at supports marijuana legalization? And this one's generally less relevant in something like survey research, but if you're doing something like rating people's behavior in a social setting, inter-rater reliability can be really, really important. Because if you're getting completely different data from two different people who are looking at the same scene, that would be a problem. We might also want to consider the validity of our variables. And validity, as I mentioned, refers to how well the variable actually measures the concept that you care about. Because you could have a really precise and really reliable variable that's just completely off. So for example, if I asked you, what's your height in inches? You'd give me a height in inches that's pretty precise. It would probably be the same every time I asked you, but it would be a really, really bad measure of how much you support marijuana legalization. So the first way of assessing validity is just thinking about, does it make any sense to begin with? And height in inches as a measure of support for marijuana legalization just wouldn't make any sense whatsoever. And so every once in a while you'll come across variables that are named something and seem to be trying to measure a concept, but the questions that are actually being asked or the different things that are actually being considered in the variable just don't make any sense. So that would be face validity. Content validity refers to whether the variable you're considering includes all relevant dimensions. And I'll come back to the marijuana example in a second, but another example of this would be if you're measuring crime and you only ask people about homicide. That absolutely does not include all the different kinds of crime that there are, so a measure of homicide only would be a pretty bad measure of crime as a whole. Discriminant validity refers to whether the measure you're looking at is distinct from measures of similar concepts. In other words, if somebody were to look at your measure without seeing what you're calling it, would they be able to tell what it is exactly that you're measuring, or could they potentially think that you're measuring something else from that? Construct validity refers to whether your measure relates to other measures in the way that it should. If it turns out that what you think is a great measure just isn't related to other things that are known to be related to the concept in ways you'd expect, you might have a problem. And finally, criterion-related validity asks whether your measure is useful for predicting something that it's supposed to predict. And so an example of this one is if you have a driving test, does it actually predict how well people are going to drive down the line? And so for each of these, I'm not going to go through an example that's a little bit more focused on our overarching example here of the marijuana legalization measure. So again, I'll just throw it up here for you to look at. We're going to have a measure. We're going to use these 5 questions to assess people's support for marijuana legalization, and we're going to combine their answers to create a variable for how much somebody supports, combine answers to each of these 5 items to get a measure for how much somebody supports legalizing marijuana. And we can also evaluate this measure in terms of how valid it is. So face validity would be, do all the questions we're asking just make sense as measures of support for marijuana legalization? And you might think they do, you might think they don't. Content validity, we need to ask, do the questions cover all important dimensions of marijuana legalization support? And is anything missing? So is there any aspect of this kind of broad, complicated issue that we're missing in those 5 questions? And if that's the case, we'd have a problem with content validity. And we have medical marijuana, recreational use, and growing marijuana, but is there anything else that we might be missing in that measure? Discriminant validity. Do the questions measure support for marijuana legalization specifically, or is there a chance that we're tapping into something else with these questions? And in this example, I would guess that you'd look at them and think I'm asking about marijuana legalization. But imagine I just asked the question, do you think it should be legal to smoke? Some people are going to interpret that as marijuana, but other people might interpret it as cigarette smoking. So in that case, we'd have a problem with discriminant validity. Construct validity. Are the answers to the questions in our measure related to other variables in ways we'd expect? So as an example, if I gave a bunch of people this questionnaire and I looked at the numbers and I found that people's use of marijuana did not have any relation whatsoever to their answers to those questions, it might make me pause and wonder how good this variable is, because you'd probably expect that people who use marijuana would be more likely to want to see it legalized. So construct validity is all about looking for expected relationships and seeing validity if those expected relationships appear. Finally, we have criterion-related validity. And with criterion-related validity, we're looking at predicting some actual behavior or outcome. So an example of criterion-related validity for our marijuana legalization support measure would be whether answers to those questions actually predicted somebody's voting behavior if a state were to vote on legalizing marijuana. So these are all different ways of looking at how good a variable is at measuring the concept that it's supposed to be measuring. So those are the qualities of good measures and things that you'll want to know about and look out for if you're ever evaluating how good a measure is. For the last bit of this lecture, I'm just going to talk about some other ways that measures can be put together. So for example, I said that our 5-item measure of support for marijuana legalization is going to combine responses to those items. And the question here is going to be, what do I actually mean by combining responses now? And as a general rule, combining variables or responses to different items in order to make a single variable often improves measure of the concept that you're interested in. One reason is that a lot of concepts are complex. So with something like marijuana legalization, asking people simply whether they support legalizing marijuana doesn't really get at the nuance of, say, medical versus recreational use, or growing it versus possessing it, or any of these different things that could factor into people's ideas about whether it should be legalized. So by having multiple items that can be combined into a single variable, you're getting a better picture of this sort of complex concept that we have. It also helps for having more refined measurement. And in general, if you're using multiple items to measure a concept, you get more precision and specificity because you have more information there. It's also less likely that you'll have a lot of noise. It could be that one of those questions on there, people would answer really erratically just for whatever reason about how the question is worded. But if you have a lot of different items, you're generally better able to see where there's a lot of noise going into your measures or just a lot of random responding and deal with it. Whereas if you only had that one item, you wouldn't really be able to tell what was noise and what were actual responses. Combining variables or combining items into a single variable also can be helpful when it comes to data analysis. But luckily for you guys, this is not a data analysis course, so we don't have to really talk about that now. So there are a couple of different ways of combining variables. If you have a nominal level variable, also known as a categorical variable, you might consider a typology. So a typology would be something that would organize cases or, say, people in a sample into different categories. And if we had two nominal level variables, one for do you use marijuana, yes or no, do you support marijuana legalization, yes or no, we could create a typology. And in our typology, we might have one group of people who both use it and support legalization, a group of people who use it and don't support legalization, a group of people who don't use it but support legalization, and a group of people who neither use it nor support legalization. So there we'd have responses to these two different kinds of nominal level variables, but we'd be creating a more detailed picture by organizing people or respondents into those different categories. A lot of the time, though, what you'll see for composite measures are something called indices. And that's just the plural of index. And this is a way of combining responses to ordinal, interval, or ratio level variables. So if you can put the categories in order, you can create an index of some kind. And the 5-item marijuana use scale that I was referring to would be an example of an index. For an index, you're taking responses to a bunch of different items or scores on a bunch of different variables, and you're either adding them together or averaging them together. If it's an ordinal level variable, you could assign numerical scores to each of the different categories, like 5 is strongly agree, 4 is somewhat agree, 3 is neither agree nor disagree, and so on, and then averaging those. So indices appear a whole lot in research articles, especially in our field, and what they do is add or average responses on ordinal, interval, or ratio level variables into a single variable that could be used to measure that concept. So in our marijuana legalization support scale, we could score each of those responses from 1 to 5, then add them all together. The higher somebody's score is on that composite added measure, the more they support marijuana legalization. And then we could use that single measure, that single index, in place of each of those 5 if we were to do any analysis, or if we wanted to just know, overall, how much does somebody support marijuana legalization. So those are really useful, and we'll be coming back to these ideas when we talk about actually designing survey items and other kind of measures down the line. So that's going to conclude the lecture for this week. And in the activity due today, we're really going to focus on some of the ideas from the very beginning of the lecture in terms of how concepts turn into measures and how they're operationalized. And with this activity, I really want you to think about the implications for any statistics that you might see out there in the real world. Because at some point, for each one of them, people had to make decisions about how the concept was going to be measured and turned into some kind of number or statistic. So the article that you're going to be looking at for this activity is one assigned for this week by Kovar, written in 2000, talks a bit about President Bill Clinton, so you can really tell that it's dated there, but the ideas in it still hold. And for the activity, I want you to think about what are the 2 main concepts that the article discusses. How were those concepts operationalized in former President Clinton's statement that 4 million adolescents smoked? And then think about whether you think that 4 million estimate is appropriate, and tell me why or why not you think that's the case. And again, I want you to really focus here on how concepts get turned into measures and the decisions that go into that process. As with the last activity, the answers to the questions on the previous slide can be between a few words to a few sentences. Don't write me any novels. Please don't spend more than about half an hour on this activity. Also, as a reminder, the activities are graded based on effort and thoughtfulness, not based on correctness, so I just want to see that you've put some thought into the questions that I asked. Responses to the activity should be posted to the discussion board by this Thursday, which will be the 17th at 11:59 p.m. And also, as with last week, comments on 2 other students' responses should be posted by Sunday, and that'll be the 20th at 11:59 p.m. And as always, feel free to ask me if you have any questions, and I will see y'all next week. And also go over the answers to the activity next week. All right, bye.